Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about the Pythagorean Theorem. Now, this is a theorem that probably a lot of you have heard of before, right? So it's a right triangle, so we have two sides of the triangle that are perpendicular to each other, and we know that they form a right angle, and then we have our hypotenuse. So our triangle has these three sides, A, B, and C. And then if this is a right triangle, we have the relationship a squared plus b squared equals c squared. So we have a standard equation that is true for any right triangle. If you know two of the sides, they're related by this equation to the last side. So as a quick example, let's do even one with very nice numbers here. But this allows you to find missing sides in right triangles. So suppose we know two of the sides of a triangle are 6 and 8. And we're missing the hypotenuse of this triangle there. Well, what does the Pythagorean theorem tell us, right? Using the Pythagorean theorem equation, we have that 6 squared plus 8 squared is equal to our question mark squared, our hypotenuse squared in that case. Well, 6 squared is 36, 8 squared is 64, 36 plus 64 is 100, so we have 100 here is equal to 10 squared, which tells us that that is our mystery side. So our third side, our hypotenuse, is going to be 10 in that case here. So two missing sides, you can find the third, right? If you were given the hypotenuse, you could find one of the kind of legs as well. These numbers don't need to be nice. Sometimes they'll be square roots and stuff as well, but we always have this a squared plus b squared equals c squared relationship. Now, that's helpful for finding missing sides. In fact, there's something a little bit different that we can say as well. That's also just a fact to do quick. We're not going to prove this today, but this is a thing to quickly mention here. If we have a triangle with sides a, b, and c that satisfies a squared plus b squared equals c squared, then the triangle is right. So what this means, this is kind of the backwards order. If you have a triangle, for example, with sides 6, 8, and 10, like we just saw, this converse says it has to be a right triangle. So it's a little bit of completeness in that it's a squared plus b squared equals c squared in a right triangle, and that's the only way this can happen. But we are focused on the Pythagorean theorem in particular. So let's take a look at how to prove this theorem. There's thousands and thousands of proofs of this. There's even books that have proofs only of the Pythagorean theorem. We're going to do one specific way, relies on a little bit of algebra here. So what we're doing is we're arranging 4 copies of the triangle to create a square. Right, so the idea here is we have our ABC triangle, so ABC, and then, this could be repeated again and again. I'm not going to write all of them out, but for example here, this is kind of some of these sides labeled. We have one side of the triangle is A, then another is B, and then our hypotenuse is C. So since we have right triangles, this forms a big square. And in fact, the centerpiece here, this is important as well. We'll see this in a second. This centerpiece is also a square. So if you look at this center thing there, because the angles in a triangle add up to 180, you can actually see that this has to be a square as well. Okay, so let's go back to our question here of what is the area of this square? Well, it is a square. Do we know the side length of the square? Yes, it's a plus b. A plus b is that. So the area is a plus b squared. So one answer to this question, we can immediately answer this question and say the area of this square is not c plus b squared here. So this is our one answer to this question. The area of the square is a squared plus 2ab plus b squared in this case. Now, as an alternate way of thinking about this, why was I mentioning that this is a little square in the middle? Well, it is, right? So another way of doing this is we have a square in the middle. What's the area of that square? That is c squared in that case. And then we have 4 triangles along the outside as well. So we could break down the big square into a smaller square and 4 triangles. So we have the area of the square, c squared, plus 4 triangles. And what are the areas of each of those triangles? They're 1/2 AB. So if we simplify this a little bit, we get c squared plus 2ab. Now, did the area of this square that we're finding the area of magically change any time when we were doing these calculations? Of course not, right? So if we look at these two equations put together, we have to have that these two values are equal. A squared plus 2ab plus b squared has to be c squared plus 2ab. So if we cancel out the 2ab's, this gives us, lo and behold, a squared plus b squared equals c squared. And this then is the formula we were trying to prove, right? So just by calculating this area in 2 different ways, we got this proof of the Pythagorean theorem. Okay, so that will be good for today's video then. Check back each Thursday for a new math tidbit, and hopefully I'll see you guys on the ZIML site for daily math practice. Put some of this knowledge to good use. Goodbye, everyone.